Hello, this is the luckiest maths teacher in the world, and today we're going to learn about linear graphs and rates. So let's start by identifying what linear graphs and rates actually have to do with each other. So first off, I'm going to put a graph on your screen that we've already seen. So this is a distance time graph. Now it's a little different from a lot of the graphs that we've been viewing in the last few lessons because it's not one straight line, one smooth straight line. It's basically four lines put together. So this one that's circled is a straight line. We have another straight line here, here, and here. Okay? So, when we're talking about distance and time, remember that the change in distance with respect to the change in time, or in other words, how quickly the distance changes with time, that is the speed. That is a rate, because it's comparing two different quantities. Distance is obviously how far you've travelled, whereas time measured in seconds here is how long it's been. They're different quantities, so comparing them using a rate. But what we actually figured out before was that the gradient, which is the rise over the run, is the rate of change. So as it says on the screen, m, the gradient, is the rate of change of the y variable with respect to the x variable. So what that means is the gradient that we've been figuring out for the last two lessons is a number that suggests how quickly the y value is changing, which is the same as saying it's how quickly the graph, the line, is going up. So remember, steeper line, higher gradient. So let's look again at our graph. So I got rid of all my circles now. So there are basically four different lines. So if we look at the distance and that the person has travelled in the first 20 seconds, so we're looking at this line here, okay? So to find the gradient of this line here, remember m, the gradient, is the rise over the run. So to get from this point to this point, the person has gone up 10 and across 20. So what that means is that the gradient, m, is rise 10 over run 20. And you should all know that 10 over 20 is a half, right? So that means that for every 2 that x is changing, so for every 2 we go across, we're going up 1. But what that means in this context is that in every 2 seconds, because x value is 2, so in every 2 seconds, we're going 1 metre. We're going 1 metre every 2 seconds, or in other words, we're going half a metre per second. So that's why it's a rate, because if we're looking at the graph, the gradient tells us how far we go up, which is how far we've travelled, per unit of time we go across. We are looking at distance over time. Distance is this one here over time, which is down here at the bottom. Okay, hopefully you're following. I'll give you another example. Let's now look at the next line. So I'm going to draw that in red. So this line here, okay? So earlier when we saw this graph a few lessons ago, we decided that this was a rest period. And that's because m, which is the gradient, is the rise over the run. Now to get from this point to the end of the line segment, at this point here, we've gone across 20. So the run is 20, but we haven't gone up. The rise is 0. So the gradient is 0 over 20. Now 0 divided by anything is just 0. So the gradient of this particular line segment in red is 0. That means that we've had 26 seconds, but we haven't gone anywhere. The speed is 0, and that makes sense given that we knew that this was rest. So the speed is 0. That's how you calculate speed. You just find the gradient of a line, because the gradient is the change in y, which is the change in distance, divided by the change in x, which is the change in time. And we all know, change in distance divided by change in time, that is precisely the speed. So I'm going to give one more example with a different graph, just to make sure you really get it. Okay, so let's try these two questions. So what is the speed in the first 5 seconds and what is the average speed overall? So the speed in the first 5 seconds, that's not too difficult. So let's look at our graph. So the first 5 seconds means from time is 0 here until time is 5, which happens here. Okay, now you can see that there's a straight line joining that. We know that the vertical axis, the y-axis, is position, meters, how far we've travelled. And we know that the horizontal axis, x-axis, is time. So all we need to do is find the rise over the run, i.e. the gradient, and we found the speed. So to go from 0 to 5, so we know that we've gone across here 5. Now, we've also gone up, so we can see here, 1, 2, 3, 4, 5. Okay, we've gone up 5. So m, the gradient, is rise, which is 5, over run, which is also 5. And hopefully you all know 5 divided by 5 is 1. Now, because the y-axis was in meters, position in meters, it's 1 meter, and because the x-axis was in second, it's per second. So 1 meter per second. In other words, in the first 5 seconds, every second that ticked by, we travelled 1 meter. All right, let's do the last question. So what we have to do here is we have to do something slightly differently. We have to look at the total distance covered and find the total time. Now, the reason that we can't just find the gradient in this particular example is because to go from 0 seconds, which is again here, to here, 12.5 seconds, the end of the journey, there is more than one line. So all we need to do is figure out how far we've travelled, okay? So that's actually really easy. So I'll just get rid of all the markings. Okay, so what we've seen is that we travelled up here. So we travelled 5 meters in the first 5 seconds. Now here, again, from 5 seconds till 10 seconds, which is here, we didn't travel anything. The gradient 0, so the speed is 0. We then came back another 5 meters down here. So all in all, we travelled 10 meters. So we travelled 10 meters, and hopefully you can all see just by reading off the x-axis that we went for 12.5 seconds. So that's the amount of time from here where it says 0, 0 to here where it hits the x-axis again. So we travelled 10 meters in 12.5 seconds. Let your calculator do the work. So 10 divided by 12.5 is 0.8. And again, it's meters per second. So that was our average speed. Doesn't mean we travelled 0.8 meters per second for the whole time. That was our average speed over the whole 12.5 seconds. So hopefully you now know how to use linear graphs to find the speed, which is a rate. This has been the luckiest maths teacher in the world. Have a great day.